So, what we have
hang
here
on.
is the...
Sorry.
You have to introduce yourself and you have to introduce the thing.
Okay, go ahead,
Do the
yeah.
proper thing.
So, Ian Cunningham from Liberty Electric Cars, setting up the PDI and LEC prototype Regenerative demonstrator. So, in my hands I have output coils, in my left hand I have green outputs from the regenerative acceleration coil. In my right hand I have a black and a red lead which is from conventional coil, which are both in the demonstration unit. So I take the outputs of the regenerative acceleration coil and I'm connecting those to a voltmeter which is here, one voltmeter which is buried. Yeah. And this is so we can infer the speed of the rotor based on the generated EMF from the core.
Okay.
So I just need to find the other lead, whether that's gone to. No, so that's okay. So I connect that in. So now just keep that up there. So that's convenient for later on when we want to short out the coil as well. So we connect on. Yeah. So this lead is purely to give us the ability to short out the regenerative acceleration coil later on during the demonstration. So keep this away from anything else for now. The next thing we have is we have a 12-volt battery and a voltmeter to measure the voltage on that battery. So I take one lead, put that on here, and then the other lead, which is also disappeared, there it is, and we put that on here. So if I now turn the voltmeter on, there we go, 12.8 volts, so it's a normal 12-volt battery. We then have a current clamp as well for measuring the current, which is going to come from the conventional coil. So only going to connect one side of this for now to avoid just shorting the coil across the battery. So we'll put the negative black lead on, the negative the battery, and then the current clamp here. I'm just going to put around the positive lead for now, but just leaving that for now because it's not required yet. So we have the voltmeter here on, which shows the speed. There's also a tachometer in this system, and also a power analyzer. So what we're going to do is, with the motor off, first of all, set the voltage from this variac, which is the input voltage for the system, to around 120 volts. Oh, I'm missing a...
Yeah, you're right.
No, there is. So they're about 70, 80, 90, 100. There we go. About 120, it's 119.9. So now turn the motor on, which puts it into an equilibrium, give it a disturbance to start the rotor turning. The other noise you can hear is a fan, which is to cool the motor that's running. We can now see the tachometer increasing. So 700 RPM, about 200 volts there. 1000 RPM, it's approximately 390 volts. So they are able to infer the speed using this voltage.
Sorry, can you say that again?
We're able to infer the speed
using
this voltage. 1500, about 550. So when we get to about 850 volts or about 2400 RPM, just start to bring the supply down a bit. So 2100 to 2. 3, so there we go, just hitting about 800 volts now, so just bring that back. And there we can see now it's starting to fall off, maybe a little bit too much. Press that one up again. So all I'm doing is trying to set this to about 840, 850 volts. I'm not doing a very good job controlling this. There we go, so and now we can see voltage on the supply to the motor down a bit, so it's decelerating slightly. So first thing we do is we connect in the conventional coil. We get about a 0.28 amp. You also see a change on the voltmeter here, and this voltmeter now is up at 12.9. We can see the speeds dropping off because the load is placed on the conventional coil, which is providing a braking effect. What we can then do, we take the output of the regenerative coil and use that and short it, so the coil is then shorted, sparks, so we get 0 voltage here. What we then see is the speed starts to increase again, and the voltage has increased further as well. And we can see this voltage now starting to creep up slightly.
Can you show this?
And this is now 0.35.
Can you disconnect it and show the increase in the current on the video?
Yeah. So we'll just
Hang on.
this.
Hang on. Okay, go ahead. So,
I'm going to disconnect this shorting lead.
right.
As I do that, you see the current
Okay.
drops off by about 0.07.
Now we're in conventional
Okay.
braking mode. When he puts the regenerative acceleration coil on, the discharging flux from the regenerative acceleration coil is being collected in the conventional coil, which is adjacent to it. So that's one of the features of the system. So take the conventional coil off,
Yeah.
and then just let it. Then you'll be in basically KX mode.
Yeah. So we'll leave the conventional coil. So this would drop off down.
What has happened? Okay.
As we're no longer charging the battery. You can see the speed here still increasing.
Let it go to
Remove the load.
let it go to 25, and I want to just see what happens when you put the load on.
What's happened with that other meter there, the gen off meter? This one right here.
It's not
Still short
reading
now.
anything.
Okay.
So now we're at about 2070, 2570, sorry, RPM. Put the load back in. It's still accelerating.
Yeah, it doesn't seem to have much effect.
It's only 0.37 on, so it's not a massive load. But if we disconnect the coil, you'll see immediately deceleration. And that's also evident in the open segment voltage of the coil. We can see that now dropping off as the motor speed is decreasing.
Can you smell the motor?
So,
Can you smell the motor yet? I can smell the motor.
okay.
So you start to smell the motor, that's what you got in your demo.
Right.
Can you smell it?
I feel it's getting warm. So
Just smelling a
maybe
heat.
we'll see if the
Hey?
You're just smelling a
on the
heat.
case.
It smells just like hot metal or something.
Yeah, that's the winding of the motor. So that's it. That's all there is to it. And again, if you had a frequency drive controller, obviously your motor would operate more efficiently, and you wouldn't have the problem with the heating, but you can get away with it. And those motors are pretty robust in that they can take a lot of abuse, so not much chance of you burning it out. You'd have to work pretty hard to burn out one of those motors. Good?